New robot combo maps radiation without GPS or a human. Two unmanned systems companies have combined GPS-denied mapping with radiation detection in a single integrated package, giving CBRN teams the ability to see inside contaminated spaces in 3 dimensions in real time without sending a person in. Emesent and Teledyne FLIR Defense announced a partnership that puts Emesent's Hovermap LiDAR payload onto Teledyne FLIR's unmanned air and ground platforms, creating a capability that addresses one of the more persistent gaps in how military and emergency response teams handle chemical, biological, radiological, and nuclear threats. The integration runs across 3 Teledyne FLIR platforms: the SkyRanger R70 and R80D SkyRaider unmanned aircraft systems, and the SUGV 325 ground robot on each of those platforms. Hovermap enables navigation and mapping in environments where GPS either doesn't reach or can't be trusted: tunnels, urban structures, underground facilities, and CBRN contaminated spaces, where sending a human operator to maintain situational awareness is exactly the kind of risk these systems exist to eliminate. Hovermap is the technical core of the partnership. The payload uses LiDAR-based simultaneous localization and mapping SLAM to generate accurate 3-dimensional maps of the environment around it without requiring GPS signal or any external infrastructure. The system builds its spatial picture from the LiDAR returns bouncing off the surfaces it moves through, continuously updating its position estimate against that accumulating map. For an unmanned vehicle operating inside a building, a subway, tunnel, or a collapsed structure where satellite signals simply don't penetrate, that capability is the difference between a robot that can navigate purposefully and one that loses orientation the moment it moves beyond the door. The CBRN application that makes this partnership particularly significant comes from combining Hovermap with Teledyne FLIR's MUVE R430 radiation detection payload on the SUGV 325. The MUVE R430 measures radiation levels as the ground robot moves through an environment. Hovermap knows where the robot is and what the space around it looks like in 3 dimensions. Together they produce something neither could generate alone: a geo-referenced 3-dimensional map of where radiation levels are elevated within a space, streamed to operators in real time as the robot moves through it. A CBRN team outside a contaminated facility can watch a spatial picture of the threat environment build in real time, seeing not just the shape of the rooms and corridors, but exactly where the radiation hotspots are located within that geometry. Stefan Raber, co-founder and chief strategy officer at Emesent, described the operational significance directly. Knowing the shape of a space is powerful. Knowing where the radiation is within that space in real time without putting a person in harm's way is an operational game changer. Our partnership with Teledyne FLIR Defense brings together GPS-denied mapping and radiation detection in a way that directly addresses what CBRN operators need in the field. Tang Ming, vice president of Unmanned Systems North America for Teledyne FLIR Defense, made the same point from the platform side. Teledyne FLIR builds platforms trusted for the most demanding CBRN missions in the world. Working with Emesent will be able to give operators a fused spatial picture of the threat environment they simply haven't had access to before. Ng added that the integration represents the direction the broader field is moving. This is the direction the whole field is heading in. And we're delivering it now through certified third-party payloads like Hovermap. That certification process matters more than it might appear. Teledyne FLIR operates an open architecture partner-enabled development ecosystem, a framework that allows third-party payload developers to integrate their systems onto Teledyne FLIR platforms through a structured certification pathway. Certified payloads go through assessment for mechanical fit, electrical interface, software compatibility, and flight performance before they carry the certification that gives customers confidence in the integrated system's reliability. Hovermap has cleared that process, meaning operators deploying it on a SkyRanger R70, R80D SkyRaider, or SUGV 325 are working with a combination that has been validated as a system rather than 2 products that happen to be bolted together. The GPS denial problem the partnership addresses is not a niche edge case. It is a routine feature of the environments where CBRN teams operate: urban structures, block satellite signals, underground facilities, provide no GPS coverage at all. Contaminated industrial sites may have structural configurations that create consistent dead zones. Any unmanned system that loses navigational capability when it loses GPS is a system with a significant operational limitation precisely where the mission demands Most lane-based navigation removes that dependency, entirely replacing it with a self-contained spatial awareness that works as well underground as it does in open terrain. The partnership also establishes a development foundation that extends beyond its current configuration. Both companies are actively developing autonomous navigation capabilities and expanding multi-sensor fusion beyond radiation detection to additional CBRN detection modalities, meaning future versions of this integrated capability could map not just radiation but chemical or biological threats within the same geo-referenced, three-dimensional picture.